Hi everyone. So today we're still in chapter 4, and our section of today is entitled General Form of a Straight Line Equation. We already explained that the straight line has an equation of the form y equal to mx plus b, okay, where m is the slope or the gradient of this line, and B is the y-intercept. What do we mean by the y-intercept? When x equal to 0, this will be cancelled. So we will obtain y equal to b. So b is the y-intercept, the ordinate of the intersection or the intersection of the line with the y-axis. Okay. So normally, when the title of this section is the general form of straight line equation. What do we mean by the general form? Okay, so the general form of any straight line, the general form of the equation of any straight line is of the form Ax plus by plus c equal to 0, and not equal to the y equal to mx plus b. But the question here is, there is any relation between the ancient form of the equation of straight line and the general form? Yes, of course. But we should keep in mind that big A, big B, and big C in the general form of the equation of a straight line are integers without not a fraction, without not a decimal, without any decimal point, and A, the condition A should be positive integer, positive or can be equal to 0. Okay, so how to rewrite the equation y equal to mx plus b in the general form? So normally it is very easy to reform or rewrite this form in the general form, to the general form. So we have y equal to mx plus b. We have this example, y equal to 3x minus 1. Okay, in the general form, we have all the terms in the left-hand side of the equal, in the same side of the equal, and the other side equal to 0. So normally, we can move all the terms to the one side. We have y here, so it is easy to move this one to this side. Or we can say that we subtract y from both sides of the equal, or either we can say that we move y to the other side. When we move y to the other side of the equal, so normally we get the opposite of this term, y. Moving y will obtain minus y. So it becomes minus y. Or, as I said before, we subtract minus y from here and minus y from here. So y minus y, they will cancel each other, and we will obtain 3x minus y minus 1. Okay? We arrange the terms, all the terms, or the terms normally after obtaining 0 equal to 3x minus y minus 1. So normally we have one side where all the terms are located, 3x minus y minus y, and the other side equal to 0. It is very easy to say that A equal to B, to rewrite it as B equal to A, because we have a balance between the two terms, or the sides of the equal. So normally here, it is easy to say that we have instead of 0 equal to 3x minus 1 minus 1, it is the same to say 3x minus 1 equal to 0. 3x minus y minus 1 equal to 0. We should verify if all the coefficients that we have here are integers, because we should be aware A, B, C are all integers. So 3, it is integer. Minus 1, it is also an integer. And minus 1, it is also an integer. And we should keep in mind that we mean the coefficient of the term, the polynomial x, should be positive. 3 is positive. So normally we get, in this way, we get finally the general form of the equation of the equation y equal to 3x minus 1. So the main idea here is to rearrange, okay, using as usual equation solving techniques. The coefficient of x must be positive and all values, as I said before, integers. So if we have, for example, y equal to minus 2x plus minus 2 third, or minus 2 over 3x plus 4. First of all, the first step is to move all the term to the one side of the equal. So it is easy to move y. Y becomes minus y, or we subtract minus y from both sides of the equal to obtain minus 2 over 3x minus y plus 4. Normally, if we, it is easy to say that we will obtain minus 2 over 3x, okay, minus y plus 4 equal to 0. But if we verify the type of the coefficient here, we will obtain minus 2 over 3 isn't an integer. Isn't an integer. It is a fraction. So normally, to convert it to, or to obtain an integer, we should get rid of the denominator. The denominator is over 3, is 3. So normally, dividing by 3 to get rid of this denominator, we should multiply all the equation. Normally, when we are working in an equation, so to get rid of a number, if it is a plus, we for example subtract minus 1. If it's divided, we multiply by 3. We multiply by 3 all the terms in the equation. So normally, minus 2 over 3 by 3, it is minus 2 over x after simplification, minus y by 3, like in the way that we multiply the coefficient, minus 1 by 3, it is minus 3y, plus 4 by 3 times 3, it is 12, and also equal 0 by 3 equal to 0, because multiplying by 0 will obtain always a 0. So minus 2x minus 3y plus 12 equal to 0. Normally, in this step, we obtain this coefficient where all values are integers, but the coefficient of x, of the polynomial x, is negative, and in the definition, the integer a should be positive. So how to get rid of the negative integer here? So it is very easy to multiply by minus 1. When we say minus 1, so we mean that we should multiply all the terms in the equation by minus 1. So minus 2 by minus 1 is 2. Minus 3 by minus 1 is plus 3. Plus 12 by minus 1 is minus 12. 0 by minus 1 is it is a 0. So these are the main steps to rewrite y equal to mx plus b as in the general form of a straight line. In the following exercise, we will apply the same steps. Normally, y equal to minus 3x minus 2 over 3 equal to 0. Okay, so we can move y to the right hand side of the equal, or we can move this one, okay, to the left hand side of the equal. It is not a big deal. It is the same strategy. Here, I prioritize to move minus 3 over 4x minus 2 over 3 to the left hand side of the equal, because the coefficient of x is negative. When moving into the left hand side of when moving these terms, so we will obtain positive coefficients. Okay, but here, for example, 1 over 2x, it is easier to move y to the side of the other terms. Okay, so when moving minus 3 over 4x, we'll obtain a plus 3 over 4x minus 2 over 3. 2 over 3 will obtain plus 2 over 3. Or we can say we add. Here we have a minus 3 over 4x, so we add 3 over 4x for both sides. And when we have minus 2 over 3, so we add a plus 2 over 3 for both sides to obtain y plus 3 over 4x plus 2 over 3 equal to 0. And we rearrange to have the first term as 3 over 4x, ax, plus by plus c equal to 0. And we mean here ax plus by. It is not obligatory to have plus here, because big B might be negative. And also we must have, it is not obligatory to have a plus here, because a C might be negative also. Okay, so we will obtain 3 over 4x plus y plus 2 over 3 equal to 0. It is not the end. Okay, if we ask, is it the end? No, it is not the end, because the values of coefficient are not all integers. So what we should we proceed? How we should proceed? Normally we have a 3 over 4. To get rid of the denominator here, okay, first of all, we multiply by 4. Okay, because we had divided by 4, we multiply by 4. The inverse operation of division is multiplication. So 3 over 4, we will obtain 3x after simplification. Plus 1 by 4, we'll obtain a plus 4y. Okay, plus 2 over 3, so plus 2 over 3 plus 8 over 3 equal 0 by 4, it is a 0. If we investigate again, we have over 3. So not all values are integers, so we multiply again by 3 to obtain 9x plus 12y, okay, a plus 8 equal to 0. In the same way here, we multiply first by 2 to obtain 1x or x minus 2y minus 3 over 2 after simplification equal to 0. Again, we multiply by 2, or we can, by one step, we multiply by the lowest common multiple, LCM of 2 and 4. Okay, LCM, the lowest common multiple between the denominators. But we can do it a different way to obtain finally, okay, 2x minus 4y minus 3 equal to 0. These are the main steps here. So we achieved our goal in the first section, how to rewrite an equation of straight line of the form y equal to mx plus b in the general form equation. Okay, and reverse way, So in the opposite way, we want to rewrite the general form equation in the form y equal to mx plus b. So we have ax plus by plus c equal to 0. So normally in this example, we have 4x minus 3y minus 12 equal to 0. The subject here is a y, the term with y. So normally we isolate it. How? So we move it to one side of the equal. So we keep 4x in the left-hand side. We keep b minus 12 in the left-hand side, and we move, or we add 3y to get rid of minus 3y. Okay? Because we have a minus 3y. To get rid of minus 3y, we add 3y. If we have plus 3y, we subtract 3y, okay, to get rid of this one, because plus 3 minus y as like terms, we add we combine the coefficients, we obtain 0y, 0, okay? So normally we have a minus 3y, so we add plus 3y for both, in both sides. Or we move minus 3y, when moving it, we have the opposite of it, so plus 3y. So normally, these equal to this part. So normally we can say A equal to B, we can say B equal to A. So 3y equal to 4x minus 12. When the term in y is the subject, we need to rewrite it as y equal to mx plus b. So the main idea here is the coefficient of y equal to 1. So to get rid of 3, we have a 3 times. So we divide all the terms of this equation by 3. Dividing 3 by 3 will obtain a 1. 4 divided by 3 is the simplest form. Minus 12 divided by 3 is equal to minus 4. So the gradient here, the slope of the straight line equal to 4 over 3, and the y-intercept is b, small b, which is equal to minus 4. Okay, so also it is easy to apply the same strategy to obtain this equation y equal to mx plus b, mx plus b, and mx plus b. Okay, you can do it by yourself. They ask us in the exercise 5 to find small b for the point below, which lie on the line with the given equation. We have an equation, for example, here, isn't in the form, the general form, or in the form y equal to mx plus b, okay? But we need to find small b, where this point lies on this line. So normally if this point lies on this line, so normally its coordinates verify this line. So we substitute, by substitution, we replace x by 2. So we will obtain for example here, if we replace, for example, x by b, we'll obtain 5b. And when multiplying y by 4, we'll obtain 8 equal to 1. So normally we have an equation of one unknown. It is very easy to solve an equation with one unknown. So 5b equal to 1 minus 8. We isolate b by dividing by 5, we will obtain minus 7 over 5. So small b equal to minus 7 over 5. In the same way, we substitute in the part b, we substitute x by minus 1 and y by b. We'll obtain minus 3 minus 4b equal to 6. So normally, we isolate, first of all, the term with in terms of b, minus 4b equal to 6. We move minus 3 to the right-hand side of the equal, or we can say we add 3 for both sides of the equal to obtain 6 plus 3 equal to 9, and then we divide by minus 4 to obtain b equal to 9 minus 4, because minus 4 is multiplied by b. Okay, easy. What we mean by the x-intercept and the y-intercept. X-intercept consists of solving the resulting linear equation after substituting y by 0. Okay, because what we mean by x-intercept, this is the repair. Okay, the axis, x-axis, y-axis. X-intercept is the line when the line intercepts the x-axis. So normally we are searching for the point located in the same time on the line and the x-axis. And we know that all points of the x-axis are having y as 0. Y as 0. So normally we substitute y equal to 0 in the equation of the straight line that we have to obtain or to search for the x-intercept. And the same way, similarly, y-intercept consists of solving the resulting linear equation after substituting x equal to 0. Y-x equal to 0. Y-intercept this line, the same line when this line intercepts the y-axis. And we know that all points that lie on the y-axis are having x equal to 0. So normally we substitute x equal to 0 in the linear equation of the straight line to obtain what we intend to have. Okay, x-intercept. So we substitute y equal to 0. We have y equal to 0. So normally, if y equal to 0, this term will be we say that we negate this term because its result equal to 0. Okay, 9x minus 5 equal to 0. So 9x equal to 5, x equal to 5 over 9. Okay, so the point that we are searching for having x equal to 5 over 9 and y equal to 0 because a y, we substitute y by 0, so y equal to 0. And we know that we are searching for the x-intercept. So x-intercept, so the ordinate of that point is none. Okay, 0. Y-intercept, substituting x equal to 0. So in the same way as we negate 9x, because when x equal to 0, 9 by 0, 0. So we'll obtain minus 2y equal to minus 5. Minus 5 equal to 0. So in this way, we have a linear equation with one unknown, easy to solve. So minus 2y equal to 5 and y equal to 5 over minus 2. When multiplying by a coefficient, if it is -1, it remains negative. And when multiplying by a coefficient, we keep for it the same sign. Okay, but when we subtracting, we will obtain, when moving it, obtain the opposite sign of it. So the point is 0 minus 5 over 2. Also, when we have a general form of a straight line, how to graph it, how to plot the line representing this equation. So it is easy. The easiest way is to find the x-intercept, okay, and the y-intercept. Okay, we find the x-intercept. So normally y equal to 6. So we find y equal to 6. 1, 2, 3, 4, 5, and 6. We mean by y-intercept 6, 0, this point. And the x-intercept, so normally x equal to minus 5. This is minus 5, 0, minus 5, 0, and 0, 6. Easy. So then we join these points with the straight line to obtain the straight line with the general equation 6x minus 5y plus 30 equal to 0. Easy, easy, easy. In the same way here, to plot any equation, any straight line with general equation, we find its x-intercept, y-intercept, and we will obtain its the 2 points, particular points to plot this straight line, because we explained before that 2 points are enough to plot or to graph a straight line. Why, by coincidence, we obtained the x-intercept and the y-intercept as 0, 0, 0, 0. Because when we have a c equal to 0 in the general form, the general form is ax plus by equal to 0 plus c equal to 0. When we don't have plus c, we don't have this constant here, like in this case, x minus 2y equal to 0. So when if c equal to 0 in the general equation, so then the x-intercept, the y-intercept are identical and congruent to the origin. Okay. Similarly, when we have the straight line with the equation y equal to mx plus b, when the y-intercept equal to 0, small b equal to 0, so the equation is restricted to y equal to mx. Similarly, we with this equation or the straight line corresponding to this equation also passes by the origin. These are the important idea of this section. Thank you for listening and have a nice day.